So how can we apply the pigeonhole principle in problem solving? So we can interpret the pigeons often as the numbers or objects, and the pigeonholes may be the properties that the numbers or these objects might possess. So we are going to prove the pigeonhole na principle by the proof of contradiction. If you remember in our class from the last semester, this is how we prove a certain statement using contradiction. So assuming we have this implication, we have the hypothesis that leads to a conclusion. So we assume not P, or the negation of the hypothesis. And with the negation of the hypothesis, it should lead to a false or a contradiction. So if negating the hypothesis and it leads to a contradiction, then we can then say or prove that P is actually true. Okay, and if P is true, then we could prove the statement. So how can we apply this into the pigeonhole na principle? Suppose none of the K boxes contain more than one object, so the total number of objects would be at most K. So what it means is that if we have K boxes, then K boxes, each of these boxes then will contain only 0 or 1 new object. Okay, so we can then say that the total number of objects would be at most K. So in other words, if we have 5 pigeonholes and each of these pigeonholes contain only 0 or 1 object, so the number of the possible na pigeons will be at most 5 as well. Okay, so this leads to a contradiction because there are at least K plus 1 na objects. So let us illustrate it. Okay, so suppose we have here 9 pigeons, okay, and we have 8 na pigeonholes. And assuming that none of these boxes contain more than one object. So what it means is this pigeonhole is only placed with one pigeon, or this pigeonhole is roosting only one pigeon. Okay, so we can then say that if we have 8 na pigeonholes, then the total number of the possible pigeons that would be placed in this would be also at most 8. Okay, so but this leads to a contradiction because there are at least K plus 1 objects. So as you can see here, we have actually 9 pigeons. So it is not true that none of these boxes will not contain more than one object. So the question is, where are we going to put this pigeon? So we can put it in this pigeonhole or in this pigeonhole or any of these pigeonholes. So let's say if we put this pigeon into this pigeonhole, then at least one of these boxes will contain more than one object or more than one pigeons. Okay, so it is a contradiction. So then we have proven that pigeonhole na principle. Okay, so let us have an example. Suppose we have a function f from a set with k plus 1 or more elements to a set with k elements, and we prove that it is not one-to-one. Okay, so to understand this better, this is actually the proof, but let's discuss it in the next slide. So we say here that, again, we have a function f that maps a set of k plus 1 with more elements to a set with k elements. So in other words, we have k na elements or k pigeons that will be mapped to k plus 1 na pigeons. Okay, so to use the pigeonhole principle, first find the boxes and the object. So what would be the boxes? What would be the that would be the set that will be mapped. That will be mapped to another set. Okay, so the boxes would be these pigeonholes, and then the objects would be these pigeons. Okay, so to prove this or to use the pigeonhole principle, so first we must find the boxes and objects, and suppose that for each element in Y, so suppose we have a set X and we have a set Y and we have a function f of x equals y that maps these two na sets. Okay. And suppose that for each of these element in y, or suppose that each of these pigeonholes in the codomain of f, we have a box that contains all elements of x in the domain of f, such that f of x is equal to y. So in other words, we have a box that contains all of the elements of x. Okay, so the number of boxes is k. So we have a number of boxes is 8. And the number of objects is k plus 1, which is equal to 9. So by the pigeonhole principle, at least one of these boxes contain 2 or more elements x of the domain. And we can see here that at least 2 elements of the domain, or the x, are assigned to the same element in the codomain. So we can see here that we mapped all these pigeons into only one box. Okay. And by the pigeonhole principle, we say that at least one of these boxes will contain 2 or more elements of the domain. And we can see that it is true. At least one na pigeon is mapped to this only one na pigeonhole. Okay, so we can then say that this function or this mapping cannot be one-to-one. So what kind of function is this then? It will be many to one na function. Okay.